So today we're going to be talking about areas of regular polygons and composite figures. So we're going to start with regular polygons. There's a pentagon right here inside of that circle. And you would say that it has some similar parts of the circle. So they both have a center, they both have a radius. And so those are the same for the circle and for the pentagon. But the new part is called the apothem. And the apothem is just from the center to the edge of the polygon instead of to the edge of the circle. And what's important there is you see that PF is at apothem. It's going to be the height of this isosceles triangle right here, because AP and BP would both be a radius, so they would be equal. And then the apothem would be that PF right there. And it is a right triangle it creates with that height because it's perpendicular. So you can use some Pythagorean theorem and different things we've learned throughout the year to be able to solve for that. The other part we need to talk about is the central angle. So APB is a central angle. I'm showing that right here. So this angle right there. And how you find the central angle is you just take 360 degrees divided by n, which is the number of sides. So that whole P would be 360 divided by 5, for example, on this one. 360 divided by 5 is 72. And then if I wanted to know each part, well, since PF, the apothem, cut it in half, divided by 2, each part is 36. So like if I needed to, I could know this is 36 degrees and that's 36 degrees. Together they make up the 72, that whole central angle. So we're going to use those parts to be able to solve this next type of example. Okay, so to be able to solve this, we need to know the formula first. So the area of a regular polygon is just 1/2 ANS, A standing for apothem, N the number of sides of the polygon, and S the side length. So the side would be like A to B, so the side length. And actually the number of sides times the side length, that's just your perimeter. So if you know the perimeter, that's what NS is. NS right here is the perimeter. So the first thing we're going to do is we are going to solve this polygon right here. This is an octagon. And I know that just from counting the sides, but we need A, N, and S. So if you're looking, we're not going to the corner. So this is not the radius. This is going to the center of the side. So 8 is our apothem. So A is 8 inches. Number of sides, well, we just counted, or I counted before. So 1, 2, 3, 4, 5, 6, 7, 8. And then the side length is we need to know how long that is. And we don't know that yet, so we're going to have to find it. So if we draw this little triangle, again, that was 8 inches. I kind of just covered that up. We're going to work to find this length right here. Well, we know this is a right angle. We know it's 8 sides, so the central angle is going to be 360 divided by the number of sides, which is 8. So 360 divided by 8 is 45. So we know that this is, the whole angle is 45. So what that means is each part right here, I don't want to make where you can't see that. Each part will be half of that. So 22.5. And again, I can't show that very well, but if this is a right triangle and that's 22.5, you could find the other angle, and you could use SOHCAHTOA if you wanted to. But we are fine to just use what we know about it, which is Pythagorean theorem. If we need to do that too, it's just you have to know what parts we already know. So what's unfortunate here is that we only know one piece of this triangle. So we can't do Pythagorean theorem. We'd have to know the radius or part of that side. You can't just do it with one number. So we are going to have to use that. So I'm going to draw this a little bigger for you so you can see it better. But if this is the 8, and we just said the whole angle is 45, that means that right here is that 22.5 degrees. Well, we want to know this piece because then those would be the same, and together that would get our side length. So we can just take that plus itself to get the side. So this would be opposite over adjacent. Again, remember SOHCAHTOA, opposite over adjacent. That's TOA, tangent. So tan of 22.5 equals opposite x over adjacent 8. So we're going to multiply both sides by 8, and then we're going to know what x is. So we're going to type that into our calculator. So 8 tan 22.5. Let me just make sure real quick. Okay, good, my mode is on degrees. So I get let's just do one decimal place, 3.3. So that means that this is 3.3 right here. And if they're isosceles, these would be equal, so they're both 3.3. So side length would equal that times 2, or adding to itself, so 6.6. So it's 6.6 inches. So now to find the area, we do 1/2 times A times N times S. So 1/2 or 0.5 times 8 times 8 times 6.6, and we get 211.2. And our units are inches. Since it's area, it will be squared. So the area of this octagon is 211.2 inches squared. And rounding could be off. Remember, I rounded at 1 decimal place here, so it could be you're a little bit off when you do this. It's okay, just make sure you're showing your work so I can look for where you rounded to make sure and give you full credit. Okay, so after you get good at doing regular polygons, you'll start working on composite figures. You might still go back to regular polygons for some of these composites, but sometimes you can just find the basic shapes and you won't have to use that if you don't need it. But a composite figure is basically just a bunch of shapes added together to make one new shape. And so they have some triangles or rectangles or circles or trapezoids. They're just made up of other shapes. So to find the area, basically we find the area of the parts and either add it or subtract it. So if you're looking right here, this is almost like a square, but its parts are missing. So I like to think of it kind of in segments. And let's see, we'll do this. So this 8 is part of this 15, which means if you subtract, this part is 7. And then this 5 is part of this 12, so this is 5. And then the rest would be 7. So now we kind of have some different parts. So we have this rectangle right here, which would be a rectangle of an 8 by 12, which I think is 96. 96, yep. So that's one part, and that will be inches squared. Then we have another, what looks more like a square, but it's supposed to be a rectangle right there, which is a 5 by 7. So 5 times 7 is 35 inches squared. And then we have this triangle right here, and it's a right triangle. And so you would have 1/2 base times height. So 1/2, 7 times 7. 7 times 7 is 49. So 0.5 times 7 is 24.5. And that will be inches square. So we're going to add up our parts. So 96 plus 35 plus 24.5. And that will be our area of our composite figure. So 96 plus 35 plus 24.5. And we get 155.5, I think it was inches. So inches square, and that will be the area of the composite figure. So just find the parts that make sense to you. You might not have broken it down the same way, but find a way for you to kind of see the different shapes, and then find the normal area like you've been doing all chapter, and then add the parts together. One thing to think about is if you have a circle, you might just want to remember that if it only shows half of a circle, you can still use pi r squared for the area, then you just cut it in half for half circle. So that might be helpful information. Okay, so with this one, we have a missing part of it. So it looks like an upside down trapezoid with this triangle cut out of it. So we really need to find the full trapezoid and then subtract out that triangle. Well, the problem is we don't have any heights really. We have this 1 little meter, but we really need the rest of this height. So it's gonna be helpful that we know that this base is 5 plus 5 plus 2, 12 meters, and that base is 8. So like for a trapezoid, we would have 1/2 height, which we don't know yet, base 1 plus base 2. So we really have to have that height. We just know it's something plus 1. And the same thing for the triangle. If I do base of 2 times height, I have to know the height. So what I'm noticing here is that these are both 6, which means it's an isosceles triangle. So this would make each of these 1. So I have a right triangle with 1 squared plus height squared equals 6 squared. and I'm going to use h just to help me remember that's what I'm finding is that height, equals 6 squared. 1 squared is 1, 6 squared is 36, subtract the 1, h squared is now 35, take the square root, and so let's see, square root of 35 is 5.9, and that's in meters. So this is 5.9, which is the height of the triangle, and then the full height would be 6.9 because it has that 1 right there. So my height of my trapezoid is 6.9. So for the trapezoid, I have 1/2 or 0.5 times 6.9 times 8 plus 12. So the trapezoid is 69 meters squared. For the triangle, it's 1/2 base of 2, height 5.9. So the 1/2 and the 2 actually cancel. So this one's just 5.9 meters squared. Since this, if you saw the original, which you can't, this part was all like shaded in, and then that little triangle piece was white, so it looked like that. So that's how I know to subtract. It helps in the book when you see it in color. So for my area, I'm gonna do 69 minus 5.9. And I get 63.1 meters squared. So with this composite figure, because of how the shape was, we actually needed to subtract it. And again, because I rounded here, your rounding might be a little bit different, which is okay. Just show your work so I can see where you rounded.